Hi everyone, welcome to Splunk User Group. and sorry, Andrew, didn't take your cue very well there. Okay, so today we're going to be talking about cloud migrations and data issues. Hello to everyone in the room as well. Nice to see you. Andrew, the only thing I can't do is the slide movement without kneeling over like this. Oh, there we go. Oh, is someone else going through the slides, or is that me?
That's me.
Oh, nice one. Today we're going to be talking about two primary things, which is cloud migration. We're going to have some engineers from Adarma and consultants from Adarma who've actually gone through a cloud migration recently, just kind of bring their experiences, some guess lessons learned, and also I'll talk a couple of slides as part of their discussion as well. Then Andrew's going to talk about Splunk and data, and then as always, there's kind of any other business just towards the end of the user group. Next slide, please. So obviously Andrew is the co-leader with myself. Andrew will be talking in the second part of the talk.
I'm just doing tech support.
Tech support at the moment. Andrew works for Lloyds Banking Group, but previously worked for Adarma, and obviously we've been co-leading this now for quite some time. Next one, please. Obviously, hi, I'm Tom, other co-leader. I haven't got my fez today, but maybe one day, maybe around conf time, I'll wear my fez, but that's the only time in the world it's cool to wear a fez. I work for Adarma. I'm a solutions architect. I've been using Splunk for over 6 years now and primarily focused on SOAR at the moment, but I still know enough about Splunk to be dangerous. Next. Our speakers today, so for the first part of this, we're going to have to I left that one on there. We've got Algi, who's a security engineer with Adarma, obviously myself, solutions architect, and then John Bathgate, who is the consultant as well. So me, Algi, and John all worked on a cloud migration project very recently. I was kind of more high-level support for them. John kind of led it from a consulting perspective, and Algi was there as the engineer doing a lot of the grunt work. Next, please. So obviously Adarma, we are the sponsor of this user group. We are the largest Splunk delivery partner for the UK. As you can see, we have plenty of awards from Splunk itself, managed service provider, specialized partner. I also believe we're going to be getting a cloud migration one soon. There's been a few of us who've gone through the advanced cloud migration accreditation now as well. So we're probably going to add some more to this next time round. And we also a Revolution Award and Splunk Partner of the Year. We also won an award at Conf recently as well. So next. So just to remind you, obviously, as you on YouTube will be aware, and anyone in the room, this is live stream to YouTube. It will be made available, public recording, sorry, will be made available after the user group finishes. If you do want to discuss topics, try to keep away from anything confidential or customer specific that you wouldn't want made public. Obviously on the stream. So again, if you're asking questions or if you've got things you want to discuss, just try and obfuscate any potential customer stuff where possible. And please, again, don't identify any specific clients you're working with unless you're happy for it to be made public. So next, please. Okay, so generally this is not sales-led at all. There is no salesy stuff from me. We're not trying to push products or push things onto people. We are here primarily to talk technical. Obviously, it is an inclusive environment, both online and in class. There's my teacher head on, but in the room as well. So obviously, if there are any questions as we're going through these things, please feel free to raise your hand or interact with us if you need to. And we are led by the technology, that being Splunk in this particular instance. So you'll hear a lot of stuff about Splunk, of course. So we do have a raffle at the end where we are sponsored by JetBrains, so you can get a free annual personal subscription to any one of the following products. And we do like a spin the wheel thing at the end of the session.
Yeah, I don't know how that's going to work today because a lot of people are online. We've not tried doing it online yet.
Yeah, so if you didn't hear that, then we're going to be winging it today somehow. Someone will walk away, hopefully, with a raffle prize. But we've kind of got a bit of a new setup, audio, visual wise, and everything else. So apologies for any teething issues that we have, but future incarnations of this will be a bit smoother, hopefully. It's not been too bad, to be fair, but you know what I mean. Okay, so without any further ado, so we're going to talk about Splunk Cloud Migrations, an overview of a migration journey. So obviously Algi and John are going to be presenting the first part of this, and then I'll pick up a couple of slides at the end. Again, just to set the scene, we have just literally finished a project with a customer, going through a migration where we had to go from nuts to bolts all the way from that discovery to actually implementing. So I think without any further ado, one of you guys is starting.
Hey, Tom. So my name is Algi, for those of you who have forgotten already. I'm just going to go quickly through what you guys will be in store for today. Tom's already done the introductions. I'll be going through Splunk Cloud overview. I will not be going through the SCMA, but if anyone has any questions on that, I can provide some information on that. John will go through in depth in terms of the cloud migration pathway, and we will both be taking you guys through lessons learned, i.e. important considerations to have in mind when you go through the migration process, and at the end we'll wrap up with any questions. Next slide, please. Okay, John, if you could move to the next slide to me.
Cool, 1 second.
Thank you. So Splunk Cloud is the SaaS offering by Splunk. It's a very powerful tool to use. A lot of clients are now migrating to cloud because they see the benefits of it. Well, what is it exactly? So essentially, it's the same sort of power, but you have less work to do when you have done the migration. For example, the search and indexing architecture is provided by Splunk. It still has the same features in terms of apps. Apps can be installed via self-service or from Splunk base, or you can install Splunk custom apps, which I will go into details later on. Maintenance and upgrade, you'll be happy to know, is provided by Splunk, i.e. maintenance of the platform itself. And of course, you're still able to use enterprise security on the cloud, and it usually comes with a separate search it. So you might be thinking in terms of this platform, what is the difference? How do we use it? It essentially boils down to what Splunk does for you and what is your responsibility. As mentioned, ingestion and data management, and indexing, storage, and searchability and data access, that's Splunk's job. Your responsibility is to, or the client's responsibility is to forward that data to Splunk Cloud, manage configurations such as source types, indexes, and other contextual details. Also managing users, data retention, configuration, and maintenance, and of course licensing and access will be the customer's responsibility. Next slide, please. And there are three main fairly simple process steps to onboarding your data onto Splunk Cloud. And that's to actually identify the data you want to move over and begin the onboarding process. To also determine the users who will have access to this platform. And there are a number of ways to access. It could be a native or LDAP or SAML user pool of users. And also, when this is completed, you can straight away start searching and creating alerts. So it's a very, very simple process. Next slide, please. One of the most important features when it comes to using Splunk itself is to have Splunk apps. And there are two ways to do this within the Splunk Cloud domain. The first is to install apps directly from Splunk base. Now, most Splunk-based apps are available via self-service. So you can easily go to Splunk base, log into Splunk Cloud, identify the app that you want to install, and install it. Some apps are not available through this process and will require raising a support ticket, for example, but this is very rare. Now, most clients do have their own custom apps, of course, and Splunk Cloud has a very unique way of allowing you to install this. Every single custom app that needs to be installed goes through a vetting agent, as I like to call it, which is called App Inspect. This vetting agent is responsible for checking the app is suitable for Splunk Cloud, and it provides a report to the SE admin. But there are limitations on the apps that can be installed this way. For example, one of the ways App Inspect looks at the app is the structure of the app. There are certain files or directories that shouldn't be in the app, and it will tell you exactly what this is. And of course, there are other security features to make sure that there is no malicious code, for example, within the app itself. So just to summarize, when it comes to installing apps, all apps are installed, vetted on Splunk Cloud, whether it's via Splunk Base or through the custom installation process. Now, there may be a reason for you to install an app or to create an app on the UI, and this is if you have an app, for example, that contains only search time extractions or alerts, then it might be simpler to just create this app from scratch rather than to go through the whole App Inspect process. Next slide, please. And now we come to the funnest part, the cloud migration pathway, and I'll pass over to John.
Okay, thanks for setting expectations high, all ready to be smashed down. So this is the part I'm going to cover. And as you can see here, we at Adarma sort of put a little pathway for the project that we recently did for a customer that in general basically included these little steps for migrating them. It's a good sort of basis to build a migration upon. And what I'm going to do is cover in depth to a degree the sort of steps that we took inside of each of these stages. So I'll just move it on here. That's where the animation looked much better on the other version of PowerPoint. That's all I'm going to say. So there's a few questions you ask when you're doing your pre-flight discovery stage. And the first thing really that you ask is, where are you on your Splunk journey? Now, this could be about, depends on who you are at this point. If you're, doing it for a customer or you are part of the business doing it for them as well. It's trying to think about how mature is your Splunk environment, right? Are we talking about, you've got a couple of log sources and a couple of universal forwarders firing up to a single indexer and search head, or are we talking about a humongously scaled enterprise environment with lots of different technical ways for getting data up to multiple search heads, for example? So it's trying to find where you are on that journey and then looking at what cloud does for you based on your scale. Following on from that, you're going to have to think about what cloud products are the best choice for you, right? So this is talking about pricing and licensing. Are you going to use any other cloud products like ES? Maybe you want to sort of take advantage of some of the opportunities that ES gives you based on your data, and you didn't previously feel like standing up the infrastructure to do that on-prem with a separate search head. So understanding at this point what you're wanting to get out of cloud is very important. Another really important prerequisite is making sure that existing infrastructure is up to date for Splunk Cloud. So what I mean by that is that Splunk Cloud generally runs on the latest version of Splunk. So you want to really make sure that your forwarders, indexers, search heads, everything else in between is at the same level, as well as the apps that you're running. Unless you're planning on porting old versions of apps up to Splunk Cloud, which is not, it's the path of war if you want to take that, you'll be downloading your apps from Splunk directly in Splunk Base. So if you're running out of the apps that say you're relying on some field extractions and you're relying on some things that these apps do, they might have been deprecated or gone altogether in the newer versions of the apps. So really, to avoid a lot of head scratching when you're doing the migration, you want to think right now, can we get everything on-prem up to date? Saves a lot of headaches. And then finally, are there any obvious considerations that need to be made before work starts? So this is kind of organization dependent, but here you really want to think about our data governance that we'll need to adhere to, our Splunk Cloud's data storage, and, are your index keeping for the right length of time to comply with your organization's information? Are there going to be change windows that you'll have to adhere to, that sort of thing? So you just want to look for those obvious gotchas at the start of a organization to make sure that you're doing everything right from the get-go. So moving on to planning and design. So once we get to the planning and design part, we follow on from that initial discussion and have a think about what does our forwarding environment look like? So specifically what we're talking about here is how are our forwarders distributed? How are we using them to get data in? Are there a lot of universal forwarders compared to heavy forwarders, other way around? The key to this is really understanding what that environment looks like. Having a deep understanding of it will help you massively in when it comes to move the data, because in the simplest way possible, if you're trying to reduce, what we're doing here, is we are trying to take exactly what those forwarders are firing into an on-premise Splunk environment and migrate that input directly to the cloud. In some cases, that can be a lift and shift operation. In others, there's going to be a lot of technical stuff involved, but understanding that forwarding environment very deeply at the start is key to that, so that you can know and plan ahead for it. Following on from that, you want to then have a discussion about whether or not you're going to do gateway forwarding or distributed forwarding. And that's for getting data into the cloud. Now, to explain both, gateway forwarding is the concept of having multiple on-premise forwarders and then routing them through one or many gateway forwarders. Those will be heavy forwarders normally. What the gateway forwarders do is they collate all the information from the forwarders and fire them up to the cloud from one single output from your enterprise environment. The benefits of this are that it's essentially only going to require an extra box. All your data is collated, and it's one single network connection compared to many that's going to go up to the cloud. The drawbacks of this are really that, if these boxes fall over, then you're going to have most of your data, if it's if it's a few boxes, or all of your data, if it's one, fail to the cloud. So that is Splunk. However, gateway forwarding is Splunk's recommended option for this. However, actually in this recent project, we moved for distributed forwarding. So that's having multiple of all your forwarders go directly to the cloud using the Splunk Cloud app. The benefits of that are that there's no extra box installation, so you're not having to stand up heavy forwarders here, extra infrastructure, which, to be perfectly honest, if you're doing a cloud migration, can be appealing not to have to think about extra internal infrastructure. The other benefits to this as well is that if something does fail or go wrong, you're likely only getting a single forwarder if it's a localized failure, compared to the huge data loss you'd get if you had a large, heavy forwarder doing all the gateway stuff. However, the fallbacks are you got to make sure that forwarding environment is watertight and up to date. So you're still going to have to do your DS stuff. You're still going to have to update all those forwarders and make sure they're all good. And also, you're going to have lots of little holes going up to the internet from your environment. In a large environment, trying to convince a firewall team to create lots of exceptions for all these devices might be challenging. So generally, I think that's why Splunk will recommend the gateway forwarding approach. Once you've got all your forwarding stuff out of the way, you really want to have a look at creating a knowledge object library. So Splunk bread and butter is knowledge objects, right? A lot of the stuff we're going to use there is on your enterprise environment, assumingly, and we want to decide what of that we're going to take up and how difficult that's going to be taking up. So we've got to look at your apps, your data models, saved searches, reports, all that sort of stuff, get it nice and collated into a single repository, and then start categorizing it, right? And by categorization, specifically for data sources, I'm meaning let's look at where the data comes from. How much data are we using from that data source? Do we need it? And these sort of questions will allow you to effectively build a plan for your migration that says we're going to migrate this data source first because we know that we'll need it early in the cloud, and we also know that it's going to be a piece of cake because it's already in the cloud and we don't have to do any weird forwarding to get it there. And then you might say, oh, well, the syslog stuff will do last because there's actually a lot of internal stuff to do with rerouting syslog information that we'll have to work with. So yeah, it's good to get a handle on your knowledge objects and data sources here. After that, you want to look at RBAC. Now, if you're an enterprise customer, you might already have an idea about how this looks, but it's good to think that, is this the right time to move to SAML from AD? Or if you've just even been using Splunk local accounts, is this the right time to move to something like SAML or AD to try and add a little bit extra security there? So yeah, definitely important to consider RBAC this early as well. And then finally, you're really going to be wanting to think ahead for any planned changes to supporting infrastructure. And by that, big one is firewall, right? We're effectively moving a lot of data that's going from one place internally to another place externally. That's going to be a lot of firewall rules and changes. You can have the perfect Splunk Cloud configuration on-prem, but if it's getting blocked at the source, there's no point. So yeah, making sure that your firewall routing is going to be configured. Things like syslog as well, because it can be quite fiddly to get syslog to go direct to cloud. I believe there are solutions that are doing that, but we normally, I think the approach in the past has been to basically collate syslog feeds onto a single syslog server and then fire that up through forwarding to the cloud. Again, that might require more infrastructure or at least some reshuffling internally. So the non-Splunk infrastructure here needs to be considered also. Finally, as well, considering change rules, there might be change freezes for firewall rules or something like that you might need to consider depending on the business. So finally, at the build and migrate stage, we are on the creation of indexes. This is really getting at the home run part now. We're making all the indexes, getting ready for data to flood on in, configuring the firewall and network stuff. So again, making sure that routing is all good, getting our data flowing up to the Splunk Cloud environment, configuring our forwarding to the cloud. So this is getting our data in at this point. That's sending the data up and receiving it in those indexes. Including dual feeding when needed as well. So let's say, for example, the customer or yourself wants to keep your enterprise environment still chugging away for a little bit, just for feature parity to make sure everything's there, or for the fact that there's still some systems relying on the enterprise information, then you can dual feed, bearing in mind, of course, that this will effectively double some of the load on the forwarders, making sure that you have enough overhead for that. And then once our data's in, generally it's best to get data in before you do this part, but then we're going to do our knowledge object migration. So that's everything that we talked about before. Get all that in, get it playing with your data, and then making sure that it's doing it all right. Everything's working as it does on-prem. And then finally, configuring any of your extra Splunk products. Big one here is ES, right? ES really requires that nice clean data to be there, sitting all organized. So that's one of the last things of the chain really to work on, is making sure that the data models are pulling for all that information. But yeah, once that's all done, you can effectively say you're migrated. But then the big part after that is data validation, which I believe Algi is going to helpfully cover for us.
Thank you, John. So data validation essentially is your last step to tick off the migration. And it's brings up a few questions. One is, what is data validation? So it's the process of checking your data sets, and in particular, the available fields and their values. Because the whole point of this migration is you're moving from one environment, the on-prem, to the cloud environment. And what you want to check or make sure is that you are getting the same values in terms of data sets on both environments. And this raises another question, which is, what does correct data look like? Well, I can answer that by telling you what wrong data looks like. And I'll give an example. If you have, for example, a authentication data set and a field name of action, you'd expect certain values such as error, success, failure, pending. If you were to then see values such as IP addresses or Boolean values, then you know that there is a problem here, and you'd start your investigation to see what this issue is. Now, bear in mind that your data validation might still be correct if you do get somewhat incorrect values, because it could be values that are carried over from the original data set that you've taken. So this goes back to the point that John made earlier about making sure you really study the environment, the client's environment on-prem, before you move on to migrate into cloud. And these steps to validating are 3 simple steps, which are: check indexes are configured correctly, confirm data is coming into indexes, and validate the data models, data sets in accordance to the common information model, which is which is reflected in Splunk's documents. Now, what are the issues that you could face when it comes to validating? Well, first one is very simple, is, and I faced this in my previous project, is that the index you're looking at has no data. So what you're actually looking for doesn't exist, which is okay. You may need to flag this up to the client to make sure that this is what is expected. And the second issue that could come up is what I mentioned earlier about the incorrect values. Next slide, please.
Cool. So so I'm going to take over. So thanks, Algi and John. Again, they gave you a really good idea there of kind of the building blocks of a migration. So I'm going to talk a little bit about the historical data migration. So some customers want to, some customers don't. It really depends. But if there is a requirement to migrate historical data up into a new Splunk Cloud instance, then Splunk professional services are required. Like, even if we are running the project, in order to utilize the processes underneath and get that data in, we have to actually use Splunk professional services, because there are stuff that has to be spun up in Splunk's own environment in order to move that data up. Now, depending on whether they already have Smart Store or whether they're able or happy to send their data online to the cloud, for example, like over the internet, then there's a couple of different ways that they would move that data. So offline is the least preferred way, because it basically is a physical transfer. So they have to send you like an AWS Snowball device, and they physically send that to the data. They have to, the customer, they have to plug it in, load the data on, send it back to Splunk, and they upload it onto the cloud layer via a Smart Store instance. Obviously, one of the main things with this is you can't be selective of the data. If you do get a offline, then it's just everything just gets copied onto this big, massive device. The only caveat with that is that it is the only way to do that. If the customer uses Windows-based indexes, then it has to be an offline one. They can't move it up. Now, the preferred one is an online Smart Store migration, which basically connects your customer indexes or indexers to the Splunk Cloud Smart Store, and then that just copies that data up over the internet. The good thing with this is you can select individual indexes. So if you don't want to move, index A, but you want to move index B through Z, then that is doable with this particular migration. But you can't do time frames. So it would literally be everything that is already in that index that would then migrate up to the cloud. One thing to consider with that is retention settings. So obviously, if you have a year's worth of data on-prem and you try and throw it up to the cloud that has a 3-month data retention, then you're going to roll off like 9 months worth of data. And if you haven't set up any of the DDAA or DDASS, all that kind of stuff, then it's likely going to literally be lost and rolled into frozen off the edge of a cliff, a data cliff, that is. Other options, there are other options as well, but it really relies primarily on the customer doing a lot of the legwork. Obviously, you can export data and re-import it through the UI. There is some collect statements that you could then send out via HEC, for example, but they're not generally recommended, especially for large data sets, because obviously you want that kind of security, I guess, of using something like a Smart Store. One thing with the online Smart Store migration as well is once it's started, you can't stop it. It is literally just gonna, it's gonna continue streaming, and again, you can't sort of just say, oh, actually, wait there. Once they've set off that online Smart Store migration, it will just basically continue. And then obviously once all the data is up in the cloud, it is then fully searchable. But the primary thing is making sure your retention settings are correct. Like I say, so that when you do push that data up, it doesn't then just literally roll into nothingness, because that is a large possibility. Next slide, please. Sorry, TV just went and I can't see the slide. Here we go. So John kind of covered it already, so I won't labor it too much, but there are multiple ways to get data into Splunk Cloud. So as he said before, the existing on-premises forwarders, you can just point those at the cloud. Actually, I'll just correct something. So it is actually best practice to send from the endpoint to Splunk Cloud. But as John also alluded to, a lot of customers don't usually like that. In order to get the data from your forwarder to the Splunk Cloud instance, there is an app you download from Splunk Cloud. You put it on your forwarders. It comes containing all the inputs, all of the indexes that it's meant to hit. All of them will come with 15 inputs by default, but it depends on the size of your Splunk Cloud instance as to how many of those are actually up and running. So if you did like a DNS query on all 15, you'd probably only get a certain amount of IP addresses back. Excuse me, depending on your license size. There is also a data manager. This is more Victoria experience. If you're still on a classic experience, you do have an inputs data manager, which is heavy forwarder in the cloud. But the data manager is actually specifically set up for AWS, GCP, and Azure data logs, because what it does is it actually configures the other side to push to Splunk Cloud rather than pulling, because it's seen as a more effective mechanism. So the AWS one, for example, will produce a Terraform file that you provide to your AWS admins, and then that will set up Kinesis Firehose to then send to the cloud rather than the cloud pulling it in. Anything that it isn't full parity with the AWS add-on at the moment, so you might still need to have a bit of a hybrid approach where you have the data manager pulling in X amount of AWS logs, and then the search head, ad hoc search head in a Victoria experience pulling in the other logs. Obviously, if you've got other SaaS inputs, then they could just be ingested, as I said before, into the search head. So in the Victoria experience, they removed the IDM, the inputs data manager, and just said, that's fine, you can put inputs onto the ad hoc search head now. And I say ad hoc because if you have enterprise security, you will have one core search head and one enterprise security search head. And of course, all of your ingestion, if you are going to put any at all on your search head, should be done on the ad hoc one rather than the ES one, because the ES one will be very heavily utilized. And then there's always HTTP Event Collector. Really great way of being able to send data over the wire. You can, secure it with SSL certificates, etc. All it needs is a token on the cloud side. There is a different inputs though. You do have to use like a HTTP-inputs and then dot whatever your Splunk Cloud instance name is in order to send it to. You don't send it directly to, for example, your search head. John's already said this, so again, quickly. So if you are sending directly to the cloud, no new infrastructure is required. But it can also be a very simple rule, although it's a very wide rule, which is why John also said the network team can get a little bit twitchy when you just say, just allow all 997 traffic to Splunk Cloud. It'll be fine. But then if you need an intermediate forwarding layer, it does require additional infrastructure. It can be heavy forwarders, but the choice between heavy forwarder and universal forwarder is really reliant on, do I need to do anything with the data before it hits Splunk Cloud? So if you're obfuscating data, or if you've got some, funky Python stuff that you do on the fly to the data, then you have to have a heavy forwarder. Otherwise, you can just utilize normal universal forwarders, but then you would also increase, for example, pipelines and things like that, as you would with the heavy forwarders as well. I think that's it, John, is it? Or is there another slide?
We just thought we'd wrap up with some learning points or important considerations you might want to take. The first being, this was mentioned a few times, is that ensuring that the existing infrastructure is up to date. Well, this is really kind of redundant if you find a client with a customer with an outdated infrastructure, but it's sort of part and advice you could give when you have finished the migration, because it just makes the cloud migration a lot easier. Removing unwanted data sources early and have a clear plan of what's going on and what's in scope of the migration. This is really important because when you come to do the data validation, you may see that you are validating data that the customer doesn't even want in the first place. So it's really important to clear that out in the beginning. Have an agreed design document and ensure that it's signed off by the customer. This is just to make sure that what you are producing is accepted at the end of the day. When installing custom apps, it may be better to build the app on Splunk Cloud UI. Again, going through the hassle of taking the custom app through App Inspect might not be worth it if it's containing a few safe searches. And finally, reviewing progress with the customer at each stage. And this is really important because going from on-prem to cloud, it could be a really different experience for the customer. And what you want to do is reassure them at each stage of what you're doing and guide them through this process, which I think it makes things a lot easier at the end. And I think this completes the first part, at least the presentation. So if you have any questions, next slide. So yeah, if there are any questions, John, I know you said you have to drop off.
Yeah, okay. All right, well, thanks for having me, guys.
Thanks, John.
Yeah, Algi, there was a question. Sorry, would you want to say your question?
What kind of challenges did you have in the last migration?
So if you couldn't hear that, it was what sort of challenges did you have in your last migration?
Need at least an hour to do. I think one of the main challenges, at least for me, was the outdated infrastructure. Splunk Cloud doesn't expect you to be 4 or 5 versions behind, so that puts you in a really unknown territory. Just making sure your infrastructure, like any software, any system, making sure it's updated is always wise. So yeah, I would say that is one of the biggest challenges I found.
Yeah, and I can jump in on that because basically with the customer they had a search head cluster. They'd tried to upgrade it in the past, but they'd failed and they'd left the deployer in a higher version. So then when we asked them to do an upgrade, they couldn't because they'd already taken a step and then they hadn't rolled it back properly. So we basically had to tell them that, look, you're going to be running at risk here, because ideally you would bring it up to parity and then everything should just work in the cloud, iron all your issues out on-prem where you've got all the access to the back end. But because they couldn't upgrade their infrastructure for us, apart from their forwarders, we had to say this is going to be running at risk then, because we can't tell if there's going to be issues with all the upgraded apps, data sources and stuff until we get it in the cloud. I mean, we were kind of lucky-ish, but that was a definite challenge when they were like, we can't upgrade the system. Okay, because they were quite a few versions behind. So, but yeah, thanks for answering, Algi. Yeah, no worries.
We're swapping over to a general guide to data. Past couple of user groups, we've sort of went quite sort of in detail in sort of very niche, sort of specific topics. So I decided, why not have a more generic topic, and what better to talk about than actual data itself. We talk an awful lot about Splunk and Splunk components. Why not the food that we feed it? Next slide, please. I'm not saying food because I see pizza in my eye line. So what is data? Sort of a general sort of concept of anything that a computer produces. If you go to the next slide, I have some examples. Got a nice big Windows event, a lovely Linux event, and a DHCP event, but you can have all sorts of different types of data. Next slide. In the context of Splunk, there's 2 different types of data based on the index that you want to put data into. You've got a main events index, which is what the majority of people are probably used to. Any event that you want to collect with meaningful data. And you've also got a smaller, more compact metrics index, which is more for like single measurements at a specific moment of time, so like your CPU usage metrics based on new servers or all sorts. I think the last time I used metrics was for a user group for the video game demonstration, because that pumped metrics from Futsa into Splunk. Next slide. There's various ways to get data into Splunk, as you probably are aware. Some of them were discussed partially in the previous presentation, but you've got your basics like your file monitor and your HTTP event collector. You could use collectd and fluentd, so like daemons on your machine to write to HEC. I think collectd's got its own module to send to Splunk. You've got technical add-ons that you can download from Splunkbase. You can build your own by using add-on builder, which allows you to create like a REST command to pull data, or Python if it's a bit more complex to pool, or turn it into a modular input. There are other more robust sort of solutions into getting data into Splunk, like syslog for Splunk Connect and Kubernetes for Splunk Connect. And these take the approach of distributing your load, your data load. For example, syslog for Splunk Connect would have you send syslog into a load balancer, which shoots out to a lot of spun up Kubernetes, I think, modules to essentially fire it on all into Splunk via, I think it's also using Heck in the background. Yeah. And there's a bunch of other methods that you probably use in your day-to-day life. Next slide, please. Now, this is the main part of the presentation, because you can put data in, but if you don't treat your data right, it's not going to go well for you and Splunk. So, next slide. In my day-to-day role, I actually do a lot of this sort of support work where I essentially have to look after infrastructure, and mostly the data components. One of the things that I look for is cases of missing data. If you were to have like your own deployment or your own infrastructure, this is one of a couple of things that you should be looking for. Is your data actually getting into Splunk? Are you getting all of your data? Like, for example, are you ingesting a file and then it stops collecting and ingesting into Splunk? Are all your folders reporting into Splunk? That's another common sort of issue, especially if you have universal folders on your hosts. Is the universal folder still sending the events into Splunk? Are your events coming in a complete fashion? I've seen many cases where we would ingest a JSON event, and because of issues, you might be missing the last couple of characters in the JSON event. Now, most of the key fields would extract fine, but if you were to look at it in like the event viewer, it wouldn't actually recognize it as JSON, so you just get the massive blob of text, and I don't think any of you analysts would want to look at that. Plus, you'd be missing possibly a chunk of your data off there. So expecting data to be complete when it isn't will cause issues if you've got alerts or reports that you've got scheduled. Next slide. This is all the problem statements. So we'll come to some solutions in a couple of minutes. Latency. Another thing to be wary of is, sure, you're getting your events in, but are they actually landing at the correct time? So are they coming in a timely manner? For example, if you run a script every 15 minutes to grab like the last 15 minutes of data, are you getting that actual 15 minutes of data go through your scripts? Are your events landing where they're meant to be? Like, are they landing in the past? Or even are they landing in the future for Splunk? Again, expecting data to be in place where it isn't will cause issues with alerting and reporting. And it's bad for correlating logs as well. For example, if you've got a change management system where you have to correlate an endpoint behavior, so like someone's made a Windows change and it's of high risk, but you've got a change management system saying this is an approved change. Normally you'd be able to correlate that and just say that's fine, it's not a risk because I've reviewed all the steps. But if you cannot correlate them because of mismatched timings, then that will cause issues with your alerts and reporting. Next slide. Final one. Do you actually understand the data that you're ingesting? I think the Windows, when you forward data from Windows, or the guides in Splunk is like, are you sure you want to ingest all these event IDs? Because there's a lot of Windows event IDs that may not actually give you data that you actually desire for ingestion. How many of the events do you actually need? Like, do you actually need all your events that you get from your source, or are you only looking for like a specific subset of events? And what are you actually expecting to get out of your data? Like, why are you collecting the data in the first place? If you are just collecting for collecting's sake, that's fair enough. That is a use case for Splunk, but if you're trying to get meaningful sort of metrics or value out of your data, you should really know what the data is that you're putting in. Next slide. So these are some points to look out for, and it's essentially going to go over those 3 points again, but with some considerations that I hope people could use as part of the sort of investigation into the data that they collect. Next slide, even though I cannot see it. Fixing missing data. So set up alerting for your missing data. There's a bit of a running joke if you go on the community Slack channel, put in ! Missing hosts or something along those lines. It'll pop up with a little message saying you're trying to find a known unknown or something along those lines. You've sort of got two problems. So if you know that you've got data missing, you can easily find, or you know what hosts are reporting in. You can sort of find periods where there are missing events by essentially just finding the gap on that data set. You can set up rules saying it's been X amount of time since I've last seen an event from this host, so I'm going to assume that this data host is missing or gone or broken. Sometimes that might not be the case. You might just have really very sporadic sort of logs that might just cause you false positives if you look at your data like that, but it's always better to alert on potentially missing data. You can't search for data that's already missing, so if you're trying to put a host in and it's not going in at all, you can't search for it because it's never made it into your indexes. So that would be your actual missing hosts. Like if you install a UF on your entire Windows estate and one of the machines has never reported in, you'll never be able to find that machine unless you collaborate with like your asset inventory, and even then, who knows if that's up to date. It never is. Never is in any company. So you can set up alerting for your missing forwarders. There's a nice, easy dashboard on the monitoring console that looks at that for you already. Essentially just looks at internal for hosts that go down. Add logging to your API scripts to know if it's successfully pulled or not. So if you're creating a custom app or custom API Python file, it's always best to have some level of logging that tells you what your script's actually doing, because the more logging, the better, unless you're logging every single transaction line by line, then that's a bit overkill. But if you have a statement saying, I've started, I've reached the end, and there are legitimately no events coming in, you can use that to collaborate with your missing data statement, because it might be the case that there's naturally no data on the other end of the API to pull. Or it could be a sign of it being broken, but it's the third party's fault at that point. So you go and talk to the third parties to see what's up. But if you know it's a sporadic source and you've got that, there's no events, it should be all clear. Sometimes you can set up your alerting to just report on missing data, but sometimes it's more vital to know when you have a significant drop or a significant rise in the amount of data that you get. Like if you were just checking if all your events from a source type were coming in and then 60% of that source type fails to show up because of some configuration mismatch, then instead of just looking for like a complete halt, I would also put in rules to see if there's a drop in your events. You can probably do this quite easily using something like the machine learning toolkit. Finally, on this slide, check your event breakers and truncation to see if it's not tacked on to another event. If you've screwed up your line breaker and you've actually got two or multiple events in one instead of just one event per actual event, then obviously that's an issue. So make sure that you've set your Magic 6 or Magic 8 if you're on a UF. Depending on the type of forwarder. Next slide, please. Fixing latency. So it's always best to check to see if the time zone is set up properly for your events. Especially it's actually quite relevant because this weekend our time zones change from BST to UTC. So if you're in the UK and your logs go a bit skewy over the weekend, it's because you've assumed that your time zone has always been a specific time zone, but then the time zones switch and your events end up an hour in the past or an hour in the future. I don't know which one, but that'll probably happen to some per soul over the weekend. The best practice is to define the timestamp used in events. If you set a timestamp in your props.conf, Splunk will use that to extract the time, obviously. If you don't set a time format or your time prefixes and all that, then Splunk will automatically try to work out what time to extract from the file using datetime.xml. And I've had cases in the past where an email would come in with a subject line with a date in it, and the date would be picked from that subject line rather than the actual alert time itself. So always ensure Splunk is looking at the correct place by setting those settings. And also, by setting those settings and making it explicit, you do speed up the amount of parsing that Splunk has to do, because it's not trying to automatically try to hunt down for a timestamp in every single event. You're essentially just saying, this is where it is. A couple of friends, _index_earliest and _index_latest can be really useful to find events that are have a lot of latency. So you can use these as well as your earliest latest statements in SPL. And what that will do is, if you use index earliest, for example, set it to at hour or at day, it will snap to at hour and tell you everything that's been ingested from that that time frame. So you can do index earliest at hour alt time, and you can see everything that gets ingested. And if something's way in the past, then you can look at that data source and remedy it. Also, you could have issues with like your SAS or an API feed, because they might not be reporting events in a timely manner. So that's a good way to determine that. Another thing to do is consider if you are searching on the actual data itself. Like, are your events landing in time for your searches to run? If your search runs and your data is not there, then obviously you're not going to get any results. Next slide. Understanding your data. So this is the sort of spiel that I had about if you have your data coming in, do you actually understand what it is? So I would encourage everyone to have a look at your data from time to time. Make sure that it makes sense. Make sure that it appears in a way that you're expecting it. Sometimes vendors like changing the log format, so you might use checking for your data as a way to sort of work out if it's changed or not, and you have to redo some steps. What props and transforms do you need to make it make sense if it's something that isn't quite human readable? Is the data worth ingesting? Again, you can ingest as much as you want, but if you are running it on-prem, for example, you have to consider storing that data and the licensing costs, although licensing keeps changing its model, so this statement might be outdated by the time this goes live. Consider what data you actually need, as some of the events can be cruft. And one thing you could also consider is there any value that you can get from your data in any other way. So for me, I use my data for security monitoring, but if you have server logs, for example, with a bunch of transactions, and you've got, I'm trying to think of the example that they show off when they, do you remember the example from Conf that they show the marketing sort of overflow for like a transaction, and you can tie like a spike in transactions with server logs. Yeah, that's what it is.
Oh, is it the,
yeah.
when the database server starts to have a bit of a...
Yeah.
Okay.
So you can combine your data to sort of produce a lot of value, and yeah, everyone loves graphs. So if you've got something to graph, go ahead, be wild. Your boss's boss will love seeing them, but if you do too many, he or she or they will expect a lot of graphs from you. So just be careful. Next slide. So make your data more usable. Next, please. So one of the things that you can do to make data more usable is to use a pipeline tool to annotate your data. There are various tools that can add extra value to Splunk. I'm not going to mention any of them by name, apart from Splunk's own one, which is Data Stream Processor. One of the examples that they Splunk like to show off is if you've got a password release system, you could get the logs from syslog into Data Stream Processor straight into a lookup for you to correlate with Windows logs, and then you can do the reverse where you've got a Windows log, go in and you do the lookup on the fly in DSP, and then it marks down that release event directly into the event. Or if you've got threat intelligence, you can pipe that into your proxy logs or your email logs, for example. There are other, there's probably a large number of ways you can annotate your data, but I'd leave that for you to imagine. Next slide, please. Common information model, briefly mentioned on the cloud presentation, but it's a way to normalize your data to be in a common standard. You have a lot of vendors with their own log formats and orderings that appear to not be compatible with each other, but by mapping everything using the common information model, you can map them to those common data sets. For example, if you get emails from Office 365, Exchange, Cisco Ironport, Semantics, email, and other companies like Gmail, they all come in different formats, but they'll all share common fields that you can map to the same field names. And then you match them to data models, so like the email data model right there. Most Splunk-based apps do have common information model mapping in the props, but some of them could be inaccurate for your actual own data set. I've experienced this myself. So you should use them as a sort of baseline for extracting or mapping, and then add your own and whatever data models you're actually wanting to get out of your data. Do this as soon as you can. I'm not going to mention specifics, but we're currently looking at some mapping ourselves. I would have liked it years and years ago. So as soon as you start onboarding your data, sim map it. It makes life easier when you get to further down the line, because you don't have rules, you don't have props, you don't have knowledge objects that expect the previous sort of way you've been working with logs with your events. Next slide. Now this is a cool one, and I will probably show the website off in a second, which will cause havoc for the stream, but don't worry. The Open Cybersecurity Schema framework is a relatively new announcement that was announced at Black Hat this year. It's a joint common model or open standard that has been promoted primarily by AWS, but Splunk's like the next major partner. You've got other companies like Broadcom. I think I looked at the list and there's like Broco, Tanium, like 20 other vendors in that opening statement alone. What it is, it's meant to remove that issue that SIM mapping is trying to solve, where different vendors are sending their logs with different field names and different attributes, and trying to remove that in theroperability. So it's agnostic to how you store the data, so it's not only a Splunk thing, it's an hopefully everything on cybersecurity should use it, and it's not limited to cybersecurity either. It sort of works by having a list of common data types, an attributes dictionary, and a taxonomy. Can never pronounce words right, to sort of describe the data. And the website does have a lot of examples in JSON format. I'll show it at the very end, just so we don't blow up the stream even further. So next slide. Oh, and we've gone to AOB. Yeah. So that's the end of data presentation. I'll try to show off the website on the fly. So this is the GitHub for site. You check schema. You can see that it's a bit like the MITRE attack, where you've got different sort of attack variants up here, but it's more like network activity or cloud activity or database activity. So if I was to click cloud activity and go into Cloud API, for example, so these are common names that classify what a Cloud API will be, and has a bit of a description, class names, and so some of these are required, some of these are optional. They all have different data types. So you should see in the future more and more vendors start using this framework as a way to set up their logs. So since AWS is quite big into this, you'll probably see it first from AWS, and then it'll filter out to other sort of vendors at some point. Yeah, this should be pretty cool, because I think a lot of time at the moment for people in the security field is trying to map these events to something that makes sense. So having a sort of a library that events are going to map against already, instead of having to do it for the common information model, will make everyone's life a bit easier. And with that, I think we will go to any other business, which I don't think there will be unless we have people in chat with messages. Jonathan Williams says the TrackMe app is also worth checking out to help of monitoring data availability. Thank you. So any other business, anyone on YouTube, feel free to put in who is the winner of the giveaway I can win. We haven't started the giveaway yet. If you want to enter, please put a comment in now, and I can set that up. So at the moment, we've only got 2 entrants. If anybody else wants in, you've got another minute. I've put slow mode on, so it might... I don't know. All right. I think that's enough. So, oh, don't look at my bookmarks. There we go. Don't look at the websites. I'm gonna have to blur that out. I mean, there's nothing bad on it, but it's just like a OPSEC sort of deal.
People always laugh at my regex crossword one.
Oh yeah. I like that one. Yeah. So 2 entrants. I'm gonna spin the wheel. Spinning. I've not spun it yet. Where do I spin it? Oh yeah. Junior. Okay, so we have a winner. So you will receive an API token for the JetBrains project that you saw at the very start of the session. And with that, I think we can finish. Let me just get OBS back up. I'm doing a lot of running. We've done that.
Yeah, just while Andrew's doing that, obviously, again, we are back in person now as well, guys. So I appreciate it's nice to jump on remotely, but come and get involved. Obviously, as you saw tonight, we had some new people. It wasn't just me and Andrew doing all the talking today. So again, if you want to get involved, please obviously join the user group. You guys already have, but again, if you know anyone else who might be interested in this Splunky stuff and is localish, then please pass the link on. We're also in LinkedIn as well. You can get into the Slack group. We have a channel in there called Edinburgh. Also, just bear in mind that Slack group also has a lot of other channels in there for all products. I'm very active in the SOAR ones, as you would expect. So please come and join us on there as well. And if you do want to present or share anything with the user group, or even potentially offer us ideas that you would want us maybe to dig a little bit deeper in for you, then obviously contact Andrew here on his Gmail account, or myself at my Adarma email, and I'll be happy to, or we'll be happy to present whatever it is you guys ask for.
Yeah.
Is that it?
Yeah.
Oh.
And so with that, we're going to close off the stream. So thank you very much.
And enjoy your night.
Yeah.